In this lecture, we're going to work an example of how you might do a sample mean confidence interval in Jupyter Notebooks. And starting out, we're going to be needing NumPy, so we import it. We're going to be using pandas, so we import it. We're going to need stats, so we import it. Now we set ourselves that we're going to do confidence of 95%, so I put in confidence equals 0.95, and I want to take a sample size of 1,000. Okay. So now I'm going to take my sample and I'm going to use random choice. And my first argument here, I put in a list. Okay. Those square brackets denote list. And in my list, I'm going to have my two categories, success or failure. I'm setting my size equal to the sample size. Okay, so my second argument. And my third one will be my probability. My probability, I'll have the first one here. This associates with the probability of success. So my probability of success is 0.025. My probability of failure is going to be 0.75. And you see here how I might be able to have a longer list if I have more probabilities associated with it. So when I generate that sample, I'll create a data frame from that sample using a dictionary as I have before. And so let's see how that goes. Shift enter. Okay. I have my data frame. Now, having created my data frame, I want to count how many successes I have. So I'm going to harken back to an earlier technique we used. So over here, I'm going to pick out a new column. It's going to be, I'm going to look at sample, and I'm going to, for every entry of sample that is a success, that's going to read true. And so I'm going to set it in a column that I'm going to call Bernoulli, for my Bernoulli random variable. So I shift enter. I have added that new column. So let's see how my data frame looks now. And we can see, okay, failure is false, failure is false, failure is false. Success is true. And we go down, we have 1,000 rows, and on everything we can see, failure corresponds to false, and success corresponds to true. And I do that because I want to count the number of successes I have. And so I can do that by taking my data frame and summing the Bernoulli column, because in my data frame it interprets false as 0 and true as 1 in the sense of the Boolean variable. And so I'll add that up, and here I'm going to get display successes, comma, success divided by sample size. So let's see this work out. Shift and enter. And so I have 244 successes. 244 divided by a sample size of 1,000 gives me 0.244. Okay, in this next cell, I'm going to take this calculation and I'm going to put it in a variable. My sample proportion will be successes divided by sample size. I take the complement of that, by which I mean 1 minus my sample proportion, because that's going to make my arithmetic a little bit more transparent in the next step when I calculate the standard error of the mean. The standard error of the mean is the square root of, x divided by n, that's the sample proportion, times 1 minus x divided by n, which is my complement. I take that product and I divide it by sample size. Then again, take the square root of the whole thing. I need my Z alpha since this is a large sample, so I take stats.norm.ppf 0.5 plus confidence, and then my margin of error is my Z times my standard error or the mean. Okay, now I've got my I want to know what are my sample proportion and my error. Okay, so this should, right, 244 just as it was before. My error is working out to, my margin of error is 0.026. And so when I get my confidence error, I'll take my sample proportion, which is my estimate of my population proportion, but we know it's wrong. It might be too big, so we subtract off the margin of error. It might be too small, so we add on the margin of error. Shift and enter. And so here I have my confidence interval. Way too many decimal places. I want to round it off to 3 decimal places here and 3 decimal places here, because basically that's how many decimals I have in my first one. We don't want people to think we have infinite accuracy. The number of decimals we write out tells people how much they can trust the numbers.